Hi everyone. So what we're gonna go over right now is the Geometry Unit 10 worksheets essentially that go with it. So what this video is gonna do is I'm gonna show you how to do the problems that are on your page basically. So if you look on your test, you'll see it's these exact problems here. I'll show you how to do them. So I want you to either write all of your work on a separate sheet of paper, take a picture, and send it to me through email. Or if you want to type directly on the Google Doc, that's fine, but you need to show your work. So if we have like a couple steps, you need to like type math, like a couple steps out. Okay? If you have any other questions about how I want it, please just ask me. Otherwise, we're going to go ahead and dive into how to do these problems. Okay, first I'm going to go ahead and just read the table and kind of dive into what it says, and then we'll go through the problems. This table is going to be used for questions 1 through 6, so it's basically this whole first portion of the worksheet. So this says a local takeout restaurant collected data on 500 customers. The table below shows how many customers bought a dessert and or bought a drink with their meal. So if we look at this table, we'll see that they surveyed 500 people. From those people, 191 people bought a dessert and also bought a drink, whereas 74 people only bought a dessert but did not buy a drink. So in total, 265 people bought a dessert. And we could go through and read the whole table like that. So if we were looking at who bought a drink, 191 people, they also bought a dessert. But who bought a drink and did not buy a dessert, that would be 139 people. In total, 330 people bought a drink, while 170 did not. So we're going to use this table to answer the questions below. If a customer was randomly selected, what is the probability that the customer bought dessert? So for probability, this is kind of a rough model, but probability, it's usually, it's called a favorable outcome. Favorable outcome. That's a fancy way of saying what you want. Like it's what they want. So what is the probability that the customer bought a dessert? A customer who bought a dessert would be the favorable outcome because like that's what they want there. And we always put that number over the total. And again, this is like kind of a rough fraction. This is like how I remember it. But it's customer bought a dessert. So we're going to go over to our table and we're going to find how many customers bought a dessert. So our probability is going to be however many customers bought a dessert. So that would be bought a dessert 265 in total. Because notice they didn't say like bought a dessert but did not buy a drink because that would be 74. So they just want to know customers who bought a dessert, 265. And that's going to go over the total number of customers that they surveyed. So it says if a customer was randomly selected, what is the probability that the customer bought a dessert? So the customer was randomly selected out of these 500 customers. So that's just going to be 500. And that would be your probability fraction there. This fraction can actually be reduced. I'm going to reduce it first, and then I'll show you guys how to do it into decimals and percentages as well. Right away, I see that it can be reduced by 5, so I'm just going to divide top and bottom by 5. That's going to give me 100 here, and I got to check this one. 265 divided by 5 is 53, and then that might be the stopping, because I don't think those are going to be in common. So that would be our fraction form. If you wanted to make it a decimal, you would do 53 divided by 100. That gets me 0.53. And if I wanted to make that a percentage, I would just scoot that percentage over twice, 1, 2, to make it 53%. So what is the probability that the customer bought a dessert? The probability is 53%. There's a 53% chance that a randomly selected customer would buy a dessert. Or you can leave your answer in fraction form as well. And I should have actually seen that if you have your numerator over 100, you can just take the numerator and make that the percent. But don't let that confuse you, but that's just a little rule. Okay, let's go ahead and try the next one. So the next one says, if one of the customers is randomly selected from the ones who bought a drink, what is the probability that this customer also bought a dessert? So this one's a little different because it says if one of the customers was randomly selected from the ones who bought a drink. So when they select a random customer, aka our total, because remember last time they selected them out of 500, this time they're not selecting out of 500, they're selecting only from the ones who bought a drink. So I'm going to go to my table and look, okay, who bought a drink, who bought a drink? In total, 330 people bought a drink. So if one of the customers is randomly selected from the ones who bought a drink, so if a customer is randomly selected from that 330, so that's going to be my new total down here, 330. And then the numerator is the favorable outcome, basically, what do they want? So if one of the customers is randomly selected from the ones who bought a drink, what is the probability that this customer also bought a dessert? So my favorable outcome here is going to be a customer who bought a dessert. But notice it's not all the customers who bought a dessert because they're only selected from the ones who bought a drink. So I'm going to go the ones who bought a drink. Basically, I'm only looking here because this is where my customers were selected from. So it's like, okay, if a customer was randomly selected from only this top row, what's the probability that they bought a dessert? Then it'd be 191. Okay, and that would be your probability fraction there. If you did want to show a little bit of work, you could show this, the favorable outcome, and then you could even put like what the favorable outcomes are if you want. I'm not sure if this can reduce. I'm going to see if 191 can divide by 3. It cannot. I don't think this is reducible. So we could go ahead and just make it 191 divided by 330. 91 divided by 330 becomes 0.5, and then it's 787878. So I get to go ahead and round that to 0.58. And then to make that a percentage would be moving over twice. So 58%. So if one of the customers was randomly selected from the ones who bought a drink, what is the probability that the customer also bought a dessert? A 58% chance. And I always like to read it again as a percentage because it lets me kind of check my answer. Because if I'm like, okay, if a customer was randomly selected from here, what's the probability that they bought a dessert? And we got 58%. So looking at 191 and 330, I'm like, oh, okay, that seems like it would be 58%. Whereas if this was like 6 and I got 58%, I'd be like, no, that doesn't make sense. Okay, so that's why I just like to read out loud too. Okay, again, go ahead and just keep all of this written on a nice separate sheet of paper. You could email me pictures or you can go ahead and type it up onto the Google Doc. Number 3. So this one, it wants you to explain how is the answer you got here in number 2 different from your answer in number 1? And they're actually referring to the fraction more specifically, your original fraction. How is the answer you got in number 2 different from your answer in number 1? So how are these two different is basically what we want to say. So remember that number 1, a customer was randomly selected from the entire 500 people. Whereas in number 2, a customer was randomly selected from the ones who bought a drink. So that's what's different there. So we can say something like, you can say in your own words. If you already have an idea for what you want to say, go ahead and say it in your own words. I want to say the original fraction, or the original probability. I'm going to put prob. No, I'll put probability so you don't think it's problem. Probability. The original probability fraction in number 1, and you don't have to add this much words. I feel like if I were you, I would literally put number 1 instead of all this nonsense. The original probability fraction in number 1 was out of 500. whereas number two was only out of, whoa, the ones who bought a drink. The ones who bought a drink. Sheesh, my handwriting is sloppy. Yeah. So the original probability fraction in number one was out of 500, whereas number two was only out of the ones who bought a drink, which was only 330. You could say something like that. I do highly encourage you to use your own words. But basically what we're saying here is that this first one, when they randomly selected, they didn't specify like randomly selected only from this group. They just said they randomly selected. That's why they randomly selected out of 500. Whereas in this one, they randomly selected only from the ones who bought a drink. So that's why this is our number here at the denominator. There's 3 more questions for you to try. Questions 4, 5, and 6. Go ahead and try them out. Show your work if you are typing it. If not, show your work on your paper. And then make sure I can see it as well. I want to see you guys try it on your own. Okay, so good luck on that. And then once you are done with number 6, go ahead and keep going. There's one more set of problems.